Welcome to the Microsoft Partner Showcase. In our previous episode, Michael Heldebrandt, a distinguished solution architect at Elastic, gave us a foundational introduction into how Elasticsearch works. In this episode, we'll dive into data chunking and how it applies to vector search. And since we're doing this just after Thanksgiving for those of us in the US, we're calling this the Too Much Turkey Tech Talk. Let's jump in. Hi, everybody. Welcome to the Microsoft Partner Showcase. I'm Brian Hitney, a solution architect at Microsoft, focused on data and analytics. And today, in episode 2 with Elastic, we're going to be diving a little bit deeper where we covered in episode 1, we covered some of the high level intro to Elasticsearch. And now we're going to go a little bit deeper. And we recognize that, at least here in the US, it's just after Thanksgiving. So we thought we would theme this a little bit. And we've got Michael here from Elastic to take us through this presentation, diving a little bit deeper into Elasticsearch and vector search and why we are putting so much attention into that lately with everything going on with generative AI. So, Michael, do you want to say hi and introduce what you're going to be talking about?
Absolutely. Great to see everybody again. Today's talk is going to be themed around, as we said, a little bit, around maybe you've had a little too much turkey, but this is our too much turkey tech talk. And what we're going to be talking about today is what we call data chunking. And this is a way to basically help improve your semantic search use cases that rely on text embedding and, vector search and things like that. And so we're going to be presenting, it's going to get technical pretty quick, and we're going to, again, circle back in future ones to talk more about the underpinnings. But today, this is going to solve a problem that everybody's got around semantic search. And so this is going to be heavily Simpsons themed. I want to have a big shout out to the Frinkiac, which is a great site that apparently has a screen cap of every single frame of every single Simpsons episode with a search box. So you can find literally anything in the Simpsons to cover thematic themes that you want to cover. So again, hello everybody again. I'm Michael Heldebrandt. I'm a distinguished solution architect with Elastic. And let's jump into basically the problem space. You sometimes you just can't eat something all at once. When we're talking about bringing data into Elasticsearch, we call it the process of ingestion. Here, for your reference, is the largest turkey ever recorded at 86 pounds from the 1980s. Was sold for $6,000 plus, apparently. So that would be definitely too much turkey to try and eat in one sitting, for example. And so an analogous thing happens when we're talking about doing semantic search and using text embedding models. Sometimes, your data is bigger than your model limits. Um, and as I like to joke, everyone's been kind of like struggling with this right now. And, basically, if you're a fan of this particular Simpsons episode like I am, until now, this was the only way to get an embedding from a large passage. You got to squeeze the document through it, and, you only get a part of it out. It didn't really work. And I've been talking to lots of people about this, and everyone at home or in their companies are doing the same thing. And you just this groaning sound of the text embedding model reaches its max token, and it basically throws away the rest of the data. But there's actually a better way, and that's what we're going to cover today. This process of basically chunking up a document. I can't believe they invented it. Yeah, it's basically similar to, I took my inspiration from here, the juice loosener, which was a particularly hilarious moment in time for The Simpsons. So this is basically the document auto chunker. It basically allows you to pour in a giant document, and it's going to turn it into little chunks for us. And again, this is more of a way to think about it. There's all sorts of ways to do it, but this one's designed to take a large document and break it up for you. And you may be thinking to yourself, well, that sounds like a lot of work. We have to, again, we're eventually going to cover all the underpinnings of, what a text embedding model is, what's natural language processing, how k-nearest neighbor works in Elasticsearch. But today, let's just talk about the three things that are going to make it work with Elasticsearch. And so, the things that you need to know is that there is this thing inside of Elasticsearch called mappings. We covered in episode 1 about how there's all these different data types. And so this is the process of defining what it is. And what really makes this possible is our new support as of 8.11. We now have the ability to do nested objects with dense vector support. So this is a new feature that's been added very recently that makes this possible. And so we need to get our mappings correct. The next thing we're going to be talking about is this thing called ingest pipelines. So again, the process of basically building a document preprocessor. So again, you bring your data to the cluster and stuff happens, and it'll just continue to eat data as long as you feed it to it. So it's going to, in this particular example be used to take a large block of text and break it up into smaller chunks so that we can then feed it through a text embedding model. So again, the ingest pipeline is going to do all the work. Please don't ever actually drink the water out of these amusement park rides. I just particularly enjoy because this sometimes we get into the fun part of scripting and things like that. So the script processor, I will warn you, it does use regular expressions and some advanced features. So it may be a spicy pepper for people to swallow if they've never really worked with things like negative look behinds and what the heck does that even mean for regular expression. But I'll go over that in a little bit of depth. So basically, I like regular expressions, and I know not everybody does. So without further ado, let's jump right in and show you. Let's see the little robot that I built in action. So we're going to jump over to a demo. So let's start with the ingest pipeline. So again, as I mentioned, what I've got here is a chunker, and I'm going to make it bigger so people can see it. So what this does is it chunks this body content. I'll show you what a document looks like and what it becomes. What it does is it's looking for, basically sentence barriers of, a period, a exclamation point, a question mark. Again, not an exhaustive list. There's, the interrobang and upside down things and things like that, depending on languages. So again, designed as a quick prototype for the English language. And what you're seeing here is we have a scripting language inside of Elasticsearch that sometimes when you're outside of the ordinary things you might need to do, like, change a field's name, there's an easy way to do that with configuration. I basically have the power of most of Java to do whatever I want. And so what you're seeing is that I'm splitting it up, and I'm even trying to be intelligent about skipping Mr., Mrs., Ms. And again, there's doctor, esquire, professor, whatever. Again, there's more exhaustive things we could do, but this should hopefully get the point across. And then what you're seeing here is that I'm able to use the full power of regular expressions. And if those that don't understand this particular content, this is saying this is a negative look behind of not looking for a Mr., Mrs. followed by a period. And we are looking behind positively for a period. And again, you have to backslash escape the dots. Regular expressions basically look like you're just pounding your keyboard with the shift key on. It's a very dense, compact way to do it. And we're saying or an exclamation point or a question mark. So again, regular expressions, go read up on the book. It's only about 400 pages from O'Reilly and Associates if you want to really, truly deeply dive in there. One of my favorite book reads, by the way. What we're then doing is basically storing it in a temporary place. And then because these chunking models sometimes want more than a single sentence, you're seeing a little bit of intelligence here of saying, if we didn't find anything, let's give up. If there was nothing to split, we've got conditional error handling. If there's just one, take the one chunk. And then the other one is that what if we've got something that's like, 50 sentences? What we're going to try and do is, use a little bit of logic to say we're going to stay under, because again, your model may have different limits. So for this particular one, we're going to stay under 400 as an example. So we can pass parameters. So these things can become boilerplate. You can tune them. What this is doing is basically concatenating sentences and looking ahead to make sure that we don't go over the limit. So we're going to go, like the Price is Right, up into, about 400 tokens if we can fit it in there. Now, what that'll do is take a big old chunk of text and basically build an array of basically these chunks of different parts of the documents, again, based on sentence boundaries, which is, again, for semantics, you don't want to cut in the middle of a sentence, at least in my opinion, because I don't think that's the right way to figure out the meaning is cutting halfway through it. So we're trying to keep the sentences together to keep its meaning. Now, the next bit of magic is that now that we have an array of sentence chunks, what we can use is what's called a for each processor. And this allows us to, again, not hard code that we're going to chunk number one, number two, number three. It allows us to just programmatically say as many chunks as I've got, zero to, basically the limits of what you could try and squeeze into the cluster. Go ahead and run a text embedding model. You see that we're calling the sentence transformer mini LM L6v2 based on the recommendations of some of my engineers. And this will now basically build vectors for each and every chunk of the document. If it was going to overflow it in the past, you'd only get those first few sentences, and then the rest of the document would be effectively invisible and ignored for semantic search. Now we're going to actually go ahead and vectorize each and every one of these. And so the next thing to know is that we need some mappings. And here's the document. So I'm going to come back to the mappings. The mappings, again, this is a very short and concise example of it, but this is all that we really need to make it work, is that we've got to define that there is going to be a nested object. And again, the the script processor is basically taking the body text and putting it into passages. And then we're also saying that there's a dense vector inside of that. And again, it's got 384 dimensions, and we want to index it for search. And we're pre-computing dot product. Again, we'll go deeper into what these are in further episodes. But know that basically this combination of magic allows us to put giant chunks of text into Elasticsearch. So again, here's the actual blog post talking about how we added the ability to do this in Lucene. And so when we run this, you can see that we have, this particular body content. But if I want to see what we actually made, you can see that I passed it just a little bit of data. But what did we actually do? So here's our body content, but here is all of the vectors that go into this particular first chunk of text. Again, it's designed to be less than 400. And you can see that we've got another one where this is another chunk in here. And now we've got another chunk and another chunk and another chunk. So again, we've taken something that was far too big to put into a text embedding model. Now we have just as many chunks as we need to basically break it up and make sense of it. And the other thing is that if you're thinking about generative AI and you found a document that happens to be 5 MB, taking the whole 5 MB and giving it to generative AI is going to take a lot of time, and it's going to take a lot of cost to be able to do that. Highlighting is one of the things that we can cover in a later session of, what part of the document is the reason that your search found it. When we're talking about semantic search, that's actually a really hard question because normally what we do is we match the tokens of the search box to the tokens that are inside of the document. Well, we're operating the world of vector similarity here. And so what we actually can now do is that show you which chunk actually matched. And that's by using our query language, which I'll move over to right now. So if I wanted to ask a question semantically of can I use multiple vectors per document now, what we're asking Elasticsearch to do is don't give me the whole document. Again, there's a whole big wall of text, and I don't want to read all of that. I want to know the subset. And so we're saying, tell me the title, because again, I still have access to parts of the document, everything had a title. And this is our k nearest neighbor vector search. And what we're saying is, I want you to tell me, because now we have nested documents, which part of the document is the reason that I found this. And so when I ask the question of, can I use multiple vectors per document now? You can see that we found, the one document we were looking for. And it is actually the adding passage vector search to Lucene. And this is the portion of the document that the semantic query matched. And so by using nested objects and our KNN search, we can now take giant documents, find the part that the user is looking for, and then give you back the part that you matched on. So you can see hopefully how this is basically empowers you now to go add semantic search to giant documents that you may need to go ahead and do semantic search on. Again, it's pretty easy to do. So just built out of a few different components there. So, just kind of to wrap it up, it's in Elasticsearch 8.11 plus, hopefully we can show you that there is a path to effortless large documents and vectors and delicious. So
First, I'm really glad to know that all that time I spent writing regular expressions to check whether a customer's email address was an actual email address or not has not been wasted, right? So yeah, that's great to see, and a really cool example of how to approach some of these large problems that really a lot of customers are facing, where you've got huge documents that you're trying to index and search. And anyway, this is a really cool example. So I appreciate you going through it, and this is really great to see. So, what are you thinking about potential topics in future episodes? Any kind of teasers for things you might like to cover in the future?
yeah, I mean, I think definitely the next couple of things we should do is probably circle back and show exactly how to do vector search and what's going on under the hood there. This was themed around like way too much text for vectors,
Hmm.
but let's maybe focus the next session on vector search and the different models that we can do, and then probably other things with natural language processing, and then other fun tours of the query DSL. I've been at Elastic for nearly 8 years and solved lots of Fortune 500 problems. So happy to share kind of the best hits, basically so to speak, of the query DSL and the search API. So.
That's awesome. That's great information, and really appreciate your expertise here. And this was fascinating. Really look forward to the future episodes. So, thank you so much for your time, and thank you everybody at Elastic to help put this together. And thank you for tuning in and watching. And hope you're recovering okay from having too much, perhaps at Thanksgiving, like we all overindulge here in the U.S. a little bit. But thanks for watching, and we'll see you next time on the Microsoft Partner Showcase. Thanks, everybody. We hope you enjoyed today's episode, and many thanks to Michael and the team at Elastic for contributing their time and expertise. If you have any feedback, please let us know in the comments. We're working on future episodes right now. Until next time, thanks for watching the Microsoft Partner Showcase.